The next unit in math is about function operations, adding, subtracting, multiplying, and dividing functions. We will do composites of functions tomorrow. So when you're adding or subtracting functions, the first thing I want you to know is that it's just like when we added or subtracted polynomials before. We're going to take our one function and we're going to add the other function. When we do this, we don't have to worry about what's inside of the parentheses unless there's something to do inside of the parentheses. So I wrote it with parentheses so you could see that I was doing f plus g, but inside of this parentheses, there's nothing to do. So I would just have 3x plus 4. And inside of this parentheses, there's also nothing to do. So I'm going to then just gather my like terms. So I have 3x and negative 5x. Those are like terms. I'll add those together. And then I also have positive 4 and positive 2, and those are like terms. So my result would be x squared minus 2x plus 6. The domain for f, because I'm just multiplying by 3 and then adding 4, there's no restriction on that domain. I can plug in any x and still multiply it by 3 and add 4. And the same is true for the quadratic. There's no domain restriction on the quadratic. The result when I add these two functions together is f plus g of x is equal to that. So sometimes your books puts the f plus g in parentheses. So if you see that notation, that means we've added f and g, and x is still our independent variable. We also wound up with a quadratic in our answer, so our domain is still going to be negative infinity to infinity, and we inherit the most restrictive domain that we have. These domains are very unrestrictive, so our domain is still going to be unrestrictive. When we add and subtract, we inherit the most restrictive domain. And I want to kind of point out what I mean by that. If one of these functions had a square root of x in it, for example, the square root of x function has a domain that goes from 0 to infinity. If we add that to something like 3x plus 4, our domain would be the most restrictive that we have. Okay. If we're subtracting, it's still the same thing. So the domain is still going to be the most restrictive that we have, which in this case is not very restrictive. The order matters because we're subtracting now. So we're taking 3x plus 4, which is f, and we're subtracting g, which is x squared minus 5x plus 2. There's nothing to do inside of these parentheses, so we just have 3x plus 4. And then because we're subtracting, we can think of that as distributing the negative to every term inside of those parentheses. So every term is subtracted. And so we wind up with minus x squared plus 5x and then minus 2. And then just like before, we're going to gather our like terms. So f minus g of x is equal to negative x squared plus 8x plus 2. And that's how you subtract with function notation. We can also multiply with function notation. I also want you to think about domain for a real world situation. So in the real world, if we're setting the price of our cell phone, it doesn't make sense for our price to be negative because then we would definitely not make any money. So our price should be from 0 until the highest we can charge. Practically speaking, of course, it can't be infinity, but I don't know how to set a cap if the price is just the price of the cell phone. And then when we have cell phones, then we also have demand for the cell phone that we have, and the demand goes down with a higher price. So if we sell our cell phone for a low price, we would have a higher demand. And our demand also has to be greater than 0, otherwise it doesn't make sense. So in order to make sure that our demand is greater than 0, we'll set 5,000 minus 10x has to be greater than 0. We're going to solve that, so we'll add 10x. So we have 5,000 is greater than 10x. Then we'll divide by 10. So we have 5,000 is greater than x. That means that our x value has to be between 0 and 5. I said 5,000, I meant 500. Otherwise, our demand is negative, which doesn't make sense. You might put a bracket on here. I'm not really sure. I might put a bracket on there because I could have a demand that's equal to 0. I have a $500 cell phone, but nobody is buying it, so I have a demand of 0. Kind of makes sense to me. And then the revenue, I wouldn't just know this, but it's kind of written up here in graphics. The revenue is going to be the price times the demand of x. So we're going to do price times demand, so we'll do x times 5,000 minus 10x. And then I could distribute that, so it would be 5,000x minus 10x. And again, we're going to use the most restrictive domain we have. So we're going to use this domain so that we have the most restrictive we have would be from 0 to 500. So when you add or subtract or multiply, you inherit the most restrictive domain possible. The other thing we can do with these problems is we could have a division problem. Pay attention to the order with division. This one says it's f divided by g, so I'm going to do x minus 7 divided by. And x minus 7 can't be factored, but 2x squared minus 13x minus 7 could be. If I go back to product, which is a times c, and sum, which is b, and I do a product sum on this, I would have negative 14 for a product, and the sum is negative 13. So if I use negative 14 and 1, that would multiply to be negative 14, and it would add to be negative 13. So that's what I will use. I'm going to remind you that that really means that before we added like terms, we had 2x squared minus 14x plus 1x minus 7. So we had this thing is equal to this, but with the like terms taken apart. And so if I now have 4 terms that can go inside of my box, so I can fit those 4 terms inside of my box. And it doesn't matter whether I put the 1x here or the negative 14x, as long as I have those on the diagonal, and then this would be negative 7. So I want my edges of my box. When I'm factoring, I'm looking for the edges. So these two edges should multiply to be 2x squared. And I have to decide whether to put the 2x up top or on the side. And the reason I would choose up top is because I want to get a negative 14. And I also want to get a 1. So I'd rather have my 2x in line with that 14. And then in order to make negative 14x with a 2x, I would need a negative 7. And in order to make a 1x here, I would need a 1. So in factored form, my problem is going to be x minus 7 over 2x plus 1, which is this edge of the box, times x minus 7, which is this edge of the box. All right, now with division, the thing you want to make sure of is that your denominator is not 0. So we want to look at our denominator and make sure that that's not 0. So we're going to do that. We're going to say 2x plus 1 can't be 0. If I solve for x, I'd have 2x can't be negative 1, or x can't be negative a half. So that's part of my domain. And the other part of my domain is that x minus 7 is not 0, or x can't be 7. Both of those came from the denominator. I don't care if the numerator is 0, but the denominator can't be 0. Now, the other thing I notice is that I can simplify this. X minus 7 can cancel out with x minus 7. And then my final answer, my f divided by g of x would be, well, I'd have a 2x plus 1, 2x plus 1 in the denominator. And my everything canceled out with what was on top, which means I have a 1 on the top, because x minus 7 divided by x minus 7 is 1. So this is my fraction, and then this is my domain restriction, which didn't get inherited from F or G, but it came about because I was dividing, and when you're dividing, you want to make sure your denominator is not 0. All right, this is a summary of today's lesson. I hope this helps. See you later.